Hi there. So just before half-term holidays, we started looking at some differentiation. And if you remember, we said that for our differentiation, if we had a function that said y equals x to some power n, then if we differentiate it, the rule was that we say we get dy by dx, and that's equal to n times x to the power of, and that power will go down by 1 to be n minus 1. So if I just go over a very quick example of this again, and I'll use slightly different notation this time. If I had something like fx equals 1 over the cube root of x, and I wanted to differentiate that. Well, the first thing I need to do is I need to change this part here into x to the power of something. It just needs to be as a power. So what I say is I know that the cube root of x, so we already know that this value is the same as x to the power of 1/3, don't we? But if we've got 1 over that, then the 1 over means that that is the same as x to the power of minus 1/3. So this function, instead of being written like this, can be written like this. These two are just equivalent. We've not done anything yet apart from rewrite it in a different way. So if we differentiate then, if you remember the sort of notation for differentiation when we do it in this is f dash x. So we're going to differentiate this, and that means that we multiply by this power and then subtract 1 from it. So if we multiply by that power, we're going to get minus 1/3 times x to the power of, and if we take 1 away from minus 1/3, take away another 1, is going to be minus 4/3. So that's that one differentiated. Hopefully you all remembered that. So what are we actually finding when we do this? And this differentiation, dy by dx, or if you're talking about it in function notation, f dash x, then we have, this tells us the gradient of the graph of y at any point. So this basically gives you the gradient of the graph of y by x. If you imagine drawing it on an axis, this gives you the gradient of your graph. The other thing it gives you is something called a rate of change. Kind of the same thing as a gradient, but we call it the rate of change, and that measures how fast y is changing with respect to x. So how is y changing as x changes? Is y getting bigger? Is it getting bigger fast or slow? How is that changing with respect to that x value? Okay, so let's look at an example here then. So if we want to find the gradient of the graph y equals 4x cubed at the point when x equals 2. What they're saying is if we were to draw the tangent to this graph at x equals 2, what would be the gradient of that tangent, that line that we draw at the graph? So first of all, as soon as you see anything to do with gradient, so as soon as gradient is mentioned and you've got a curve or a graph, that should be telling you that what we're going to be finding is dy by dx. So dy by dx gives us the general equation of any gradient, the gradient at any point on the line. So to differentiate, if your original function here is y equals 4x cubed, to differentiate you're going to multiply by this power and then take 1 away from it. So times by the 3, that 4 is going to become 12, and 1 away from the 3, that becomes 2. So this gives us the general equation for the gradient at any point on this curve. So to work out the gradient when x equals 2, all we're going to say is, well, when x equals 2, that gradient, dy by dx, is going to be 12 times 2 squared, which will be 12 times 4, so the answer must be 48. So when x equals 2, this gradient is 48. Okay, now you've seen this question, what I'd like you to do is, in your textbooks, turn to page 366. The exercise that you're going to be looking at is exercise 12D, and I want you to have a go at, on that page, question 3. And the answers are at the back. You can mark that and then come back and watch the next video.